We'll proceed in summation and integral calculus. Summation and integral calculus, the area in which we are proceeding with the discussion. Okay, so what is the scenario right now? Hoop, hoop, hoop. It went here only. Okay, so we are talking about the calculating the circumference through vector. Means we are doing more towards vector now. If I have a function, then there is x and there is y. If it is two dimensional. If I have a function, if I have a function, then it is two dimensional. This is x-axis and this is y-axis. Two dimensional. Okay, if I take any point P here, then it has x-axis intersection and it has y-axis intersection. Okay, how much y changes if I change in x? That is called dy by dx. Okay, how much y is changing if there is change in the x? Dy by dx. But change in x, how much y is changing? That we also get through normal division also. That we get through normal division also. Like if I take two bags, okay, one bag has orange and another bag has tamarind. One bag has orange and another bag has tamarind. Okay, in that fashion, one bag uh, at any time I see in orange bag and there are four oranges. At same time, if I see in tamarind, then there are 12 tamarind. Makes sense? There are two bags. One bag is has orange and another bag has tamarind. Now in orange bag, at any moment the number of orange is 4. At that time, number of tamarind in tamarind bag is 12. After some time, I am seeing in the orange bag number of orange is 10. In tamarind bag it is 30, 30. Up, up, up. Okay, I can draw a chart now. This is orange and this is tamarind. Okay, it looks like something like this graph. Means this graph means at any moment if I take orange and then see the tamarind, it is triple of it. Okay, how much is the tamarind per orange? 3. 30 by 10, 3. 12 by 4, 3. At any moment, the number of tamarind per orange is 3. Any moment. Okay. Any moment, the number of tamarind per orange is 3. Very nice. What about? So the graph is like this. If this is orange and this is tamarind graph, then this is tamarind axis and this is orange axis. Then this is the graph. This is a straight line. If there is a straight line, then it is a linear equation. This is called linear equation. What is linear equation? Y equal to constant into another variable. Here it is y equal to 3x or tamarind equal to 3 orange. That is the equation. Okay, okay, what else it can be? If this is orange and this is tamarind. Okay, this is the graph now. This is non-linear. This is not a straight line. If this is not a straight line, then at any moment if I see orange, then tamarind, orange 4, then tamarind is 16 anytime. Then I understood it is 4 times. Orange is 4, then tamarind is 16, 4 times. Okay, after some time I see orange as 10, then tamarind is 100, hope, 10 times. Okay, but actually it is a square and it is a non-straight line. In this fashion, division will not work. If I say how many tamarind per orange, then you cannot say it is sometime. One time I saw it was 4. One time I saw it is 10. Division will not work. Okay. If I draw a graph, then tamarind equal to x square, y equal to x square. At any moment, if orange is x, then tamarind is x square. Tell me per unit of orange how many tamarind are there? Not defined. That is the answer. If it is not a straight line, not defined. Not okay. Per unit of orange has how many unit of tamarind? Not defined. It is a non-linear curve. We cannot estimate. What you can estimate? We can estimate per unit change in orange brings how many unit of change in tamarind at a particular point in the orange. Everywhere per unit change is different. That is called dy by dx. Now division is gone if it is non-linear. If it is linear, then division will work. If it is non-linear, then differentiation will come. dy by dx. X square means dy by dx equal to 2x. At any moment when x is x1, means number of orange is x1, any x can be 2, 3, 4, 10, any. At any moment when number of orange is x1, at that time change in tamarind per unit change is a new word. Change in the number of change in tamarind per unit change in orange, when orange count is 10, then it is 2x, 20 at that moment. At that moment it is 20. When x is 4, then it is 2 into x, 8. Okay, at that time dy, because if y equal to x square, dy by dx equal to 2x. When x is 4, at that time rate of change what we see is 8. Per unit change in orange means when orange count is 4 and here it is 16. If you add one orange here, per unit change, if you add one orange here, you have to add 8 oranges there, more or less. Means it will become that side 23 if it is 5 here. It should be 25, more or less. If it is 10, then if it is 10, it is 100 here. If you add 1 here, then it will be 2x. Means 20 you have to add here. More we go up, more nice it will be. It should have been 121, now it is 120. If it is 20, then 2x, 40 you have to add. Okay, if it is 20, then 21, 1 if you add, then 40 you have to add at that moment. So 20 means 400, 21 means 440. What is 21 into 21? That means 21 into 1 is 1, 2, 42 into 2, 441. We have 440 approximately. Means this is the division. Anyway, we are talking about bringing vector into the summation integration, summation and integral calculus. Summation, dividing problem into n number of parts and then bringing a vector into discussion. Because that science, if you understand, then we can tackle probability distribution also. Because probability distribution can be in two phases. One phase is repeated summation. There also probability distribution is there. It is called point mass function. There also function is there. And in continuous function, that is called probability density function. There also function is there. Okay, how I can use this function? How I can use term of vector when we think about this function? Where vector comes into the picture? People generally, they tend to be happy when they see calculus. Calculus, now it is understandable where calculus comes into the picture. If I have a two independent component, I mean if I have two variable, one is orange and one is tamarind. Tamarind is dependent upon orange, but they are orthogonal to each other. That is a different thing. Because tamarind is completely different and orange is completely different thing. They are orthogonal to each other. But rise in the tamarind, if I have a wave like this, then rise in tamarind means that is the vertical component and orange is horizontal component. Vertical component is dependent upon orange and it is non-linear. This is not linear. This is a curve. It is not a straight line. If it is a non-linear relationship is there, then we cannot say straightforward how many tamarind per orange. That will be a kiddish question. What is change in tamarind I see per unit change in orange at a particular point of the orange? That is exact word. And this is calculus now called differential calculus. Here calculus comes into the picture. You cannot say how many tamarind per orange. Tamarind is x square and orange is x. X square by x, x. X is the tamarind per orange. That is false. It will not work. 2x. That is highly different. 2x. Highly different. Anyway, if it is sin x, then sin x by x is not true. D sin x by dx, that will come as cos x. That is completely different than sin x by x. Completely different. Okay, how much change if orange is x, then tamarind is sin x. Orange is 0, then tamarind is also 0. When orange is pi by 2, then tamarind is 1. That is the relationship. Or if orange is x, then tamarind is 10 into sin x. If orange is pi by 2, orange tamarind is 10. 0, 0. That is the relationship. What is what is change in tamarind per unit change in orange? Cos x. Cos 0 is 1. Means if at 0, if I have 0 orange and 0 tamarind, if I add a little 1 unit of orange, 1 unit can be very small also. 1 unit of orange at that moment, and that moment someone has to add cos 0 is 1. Someone has to add 1 unit there also. Okay, when it is pi by 2 and here it is 10, 10 sin x we have said. Oh, 10 cos x will be result. When we add 1, when it is 0, 10 I have to add here, 10 into 1. When it is pi by 2, then here we have 10, 10 sin x. At that time, if I add 1, then cos x pi by 2 is 0. No need to add anything. Means that is the relationship where calculus comes into the picture. But beyond that, why we need a vector? That is the question that is arising. Why we need vector? Okay, if this is x-axis and this is y-axis, if I have any point here, there are two sources. Now, if I see carefully, x-axis and y-axis, we can say there are two energy sources. Now, one energy source is this, and one energy source is this. If I have a, if I really have two energy, consider one energy is coming from negative of y-axis and it is traveling toward origin, and one energy is coming from the negative of x-axis and it is coming to origin. They are meeting here. Then they will proceed in this direction between x-axis and y-axis. Depend upon the strength of the energy. They will proceed like this. Okay, means there are two sources of energy. If there is x-axis and y-axis, there are two sources of energy. One energy is going towards y-axis and one energy is coming from negative axis and going toward positive x-axis. They meet at the origin and they go, since they met at the origin, there is one energy source. It will flow like this. Okay, then you said that y is dependent upon x possible. What is y dependent on x is, if energy is coming from this side, what is the strength of the energy? Strength of the energy. Okay, that we can be computed like if energy source is 10x, 10I. What is your energy? 10I means energy is moving towards positive x-axis and it has magnitude of 10. Magnitude of 10. What is your y? Y energy is moving like this. It has direction of j, but it is x by 2. X by 2. X by 2 means where the x by 2 means if I say this energy, where this energy right now, what is the x? Then y energy will have x by 2 strength, x by 2 j. X by 2 j means it has a strength of x by 2. If x is at zero point 0.5 minus 0.5 minus 5, then y is at minus 0.2.5 means it has a strength half of x. So strength of the energy that is flowing along along y axis, it is strength is changing as per the strength of x. What is the x now? If I say what is your energy moving in x direction, say it is xi rather than 10I, say x. I'm sorry. If I say y is x by 2, the energy that is moving here is x by 2, x by 2, and x energy is 10, then it is 5, always 5. Consider the x energy in xi means wherever x is, that much is the xi. If energy is at minus 5, then minus 5i, something like that. Then means it is changing. Energy is moving along x axis and energy strength is changing. Makes sense? If energy is, if I take a position at 10 on the x-axis, energy is 10i. Energy is 10. If that point, if some correlate the y-axis, then it will be 10 by 2. Okay, something like that. Someone can think about it. Okay, anyway, so I have two energy source. One energy source is along x-axis, one energy source is along y-axis. We call it orange and tamarind also. Anyway, now if I say what is the tamarind change in tamarind per unit change in orange, means if I have orange count here like this, at this moment, if I make 1 unit change in the orange, consider when orange is here, then tamarind is here. This is the point called x comma y. There is a graph now. Graph means when orange is going like this, then how much tamarind is going like this. One graph can be like this also, x square. This is the graph. X square is the graph. Okay, if I at any point x orange, I have tamarind, that is the vertical. If I make 1 unit change in x, then how many change in tamarind I can see? From x here to here it went. If I go 1 unit, then here it goes. There is this much change in y, provided there is 1 unit change in x. Or if I say no, I did not make 1 unit change, I made delta x change, then there is a delta y change we seen here. Then delta y by delta x is called dy by dx. That is the change in the tamarind I say C per unit change in the orange at any point x. Any point x, because everywhere dy by dx will be different. Okay, so this is the dy by dx. What is problem here? Problem is that we are seeing the change in y with the change in x. Y is always in the vertical direction. Y is always in the vertical direction. X is always in the horizontal direction. But no one is talking about the direction of this curve. Okay, if I say this curve, okay, if I talk about this curve, if I talk about this curve, no one is talking about going along the curve. No one. Y will go along vertical. X will go along horizontal. Whatever going along the curve, I don't know what is going along the curve. If I talk about calculus differentiation, dy by dx means at any point, this is x-axis, this is y-axis. At any point, if I change 1 unit change in x, then how many unit change in y? No, I don't want that. Tell me, if you make 1 unit of change in x, then how much length will change? How? That I don't know. I can tell you if there is 1 unit of change in x, then if x goes like this, then there is a change. How many unit of y will change? No, that I don't know. Tell me if this is x-axis, if this is if this is x-axis, orange, then if I make orange, consider this is count is like 1000. This is 1000, 2000, 3000, 4000 oranges. Now, if I make 1 orange change, 1 unit change, then how much tamarind will change? This will go like this and go up like this, and it will make intersection in this section of this curve. Then y will be like this. If one orange is changing at what location? Okay, when orange count is 2020 at that moment. When orange is 2020 at that moment, the tamarind is 2020 whole square. Because it is x square, right? 2020 whole square is the tamarind. Means it will be very big. Anyway. Now at that moment, if I make 1 unit of orange change, if I go make interception, how many unit of tamarind change I can see? Then that is the dy by dx. dy by dx will come in algebra. Okay, that is come in a variable of x. There you have to put x value. If it is x square relationship, it will come as 2x. Now you are free to get the dy by dx at any x. If you put 2020, then it will 2 into 2020. At that moment, 1 unit change of orange will give that many unit of change in the tamarind. Okay, what about when number of orange is 10, then 2x 20. Here, 1 unit change in orange will add 20 tamarind in the 20 tamarind bag. But when x is 2020, then 1 unit of orange change will add 4040. Here 20, when it is 10, then 20. And when it is 2020, then it will 4040 it will add. Please see the difference. Okay, but whatever it is, no one is giving this length. Why you are worrying about this length, this length, this length? You are happy with the tamarind and orange, right? No, no. There is implication. I want this length. If there is 1 unit of orange change I see like this, then how much this length would change? The curve, if I draw a curve of orange and tamarind, it will draw a curve like this. Yeah, it will draw a curve like this. True. That is y equal to x square. If at any point x, if I make 1 unit of change in x, if I go up, it hits begin point hit here and end point hit here. Tell me this length, how much length I am seeing. If length of on x axis is 1, per unit length change in x per unit means 1 unit change at any point x or x1. If it is goes up, then how much length I see? How much height I see, that is dy by dx. How much length I see? Sorry, there is no measurement of it. If we talk about length, there are only two measurements is here. One is y, that is vertical, and one is x, that is horizontal. There is nothing called third. Okay, what is your length? Now people are analyzing it very closely. No, what is what you want? You want curve length per unit x, right? Curve length, if I take any point on the curve length, if I take any point on the vertical, if it is vertical, if I take points on the vertical, then x is not changing, only y is changing. If I take point on horizontal, then y is not changing, only x is changing. If I take a point along this line, then x and y both are changing. Makes sense? Both are changing. If both are changing, then I have to use a terminology which address both of them, which address both of them. That is called vector. Vector means if this is the graph, if this is the x-axis and this is the graph, if I have any point here x1 comma y1, I have another point here called x2 comma y2, then if this is the origin, then there is a line like this, goes line like this, and that equation is xi plus yj. No, 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 no. Tell me in yax. Forget the yax era is over. Now there will be a line connecting origin and this point x1 comma y1. There is a straight line which will connect, and it is called position vector. That is x1i plus y1j vector. What about another point? That is x2i plus y2j. Okay, then if I make these are resulted because I made a delta x change, or if I made 1 unit of change. If I make 1 unit of change, or if I make delta x change along x axis, consider I made delta x change. There is at any point x, at any point x1, this is x1, this is x2, x2 y2, x1 y1. At any point x1, I made delta x change, that is x2 minus x1. At that point, if I take, then it goes here, then how much is the distance it covered? Okay, that is, if this is p1 vector, This is P2 vector. If I subtract P2 and P1 vector, it will give a vector which connects this x1, y1 to x2, y2. If I calculate the length of this vector, more or less it will give length of the curve. No, no, no. Completely wrong. It will give length of the straight line, not the curve line. Okay, that is true. It will give the length of the straight line, not the curve line. But if delta x tends to 0, then if this x, if this delta x, x2 minus x1 is tends to 0, infinitesimally small, in that fashion, P1 and P2 will be very near to each other. It can be described as a line on the curve 1. Okay, these are the things that personally I don't like. But how it would work, that we will see. Means if I say D chain in P, that is P2 minus P1 vector. P2 is the x2i plus y2j, that is P2 vector. P1 vector is x1i plus y1j. P2 minus P vector. P2 minus P vector, that is x2 minus x1i plus y2 minus y1j. I can say delta P, change in position vector. Delta P, because of delta x change on x-axis, delta P by delta x. If I divide someone like this, it becomes per unit change along x-axis brings how many unit of change in position vector. That is x2 minus x1i plus y2 minus y1j, where x2 minus x1 tends to 0. No, no, tell me the amount, not in vector. The amount will be x2 minus x1 whole square plus y2 minus y1 whole square root. Means magnitude of delta p by delta x, or dp by dx, magnitude of dp by dx. Means per unit change in x at any point x brings how many unit of change in magnitude for the position change in position vector. Means it is giving us the actually the length that it is traversing when there is a unit length change in x-axis. That is magnitude of dp by dx, dp by dx. Okay, can I use it to calculate the length of this line? Length of this line from 0 to 10. What is the length of this line? When y equal to x square with your fundamental. Okay, this is x-axis and this is going like this. This is x equal to 10. Then y equal to 100. Tell me this length of this line. Okay, then if there is one unit change, that is one unit means not one. 1, 2, 3, 4, 10. That is not one. One means any very small, it can be a picometer also. This is meter, 1 meter, 2 meter, 3 meter, 10 meter. A 10 meter height is 100 meter, very, very high. Okay, per unit change at any moment x. Okay, at that time, how much unit of this curve length I see, there P will come. Vector P, it represent x and y both. Okay, now we have dp by dx. Now let's divide this 10. Let's divide this section 0 to 10 into n different parts. 0 to 10 into n different parts. Makes sense? If what is your n? N is 10,000. What is your problem? N is 10,000. Yeah, that is looks better. Then what? Then tell me what is the length of this curve for any section? If I divide 0 to 10 into n different parts, length of the any part, ith part, length of the any ith part is how much? Then it is 10 by n. Okay, understood. Then what is the length of this section? Any ith section, that length, this length is 10 by n. Then what is length here? That is dp by dx into dp by dx is per unit, per unit change in x brings how many unit of change, how many unit length change into delta xi. Ith section width is, if one width is there, then that much length it is addressing. If delta xi width is the actual width, then how much width it will address? So ith section length is dp by dx into delta xi. dp by dx, where dp magnitude. What is p? P is xi plus yj. What is y? X square. It is xi plus x square j. We are taking magnitude of it. Makes sense? Magnitude of it, that will come as x d of xi. I'm sorry, x square plus x to the power 4 square root, that it will come. Okay, dp by dx, or I will differentiate it first and then calculate the magnitude. We will try. So let's say dp by dx. dp by dx, if I go, dp by dx, if I go, it is xi plus x square j. dp by dx will resolve into I plus 2xj. Now magnitude, because we want the length. Per unit change in x brings 1 square plus 2x whole square root of magnitude. Okay, if that is the case, then delta xi, now this is fx, function over x. What is function over x? The length, what per unit change in x, how much length it is bringing, that is 1 square plus 4x square root. This is a good sign, good case to say this is function over x, whatever it is. For any ith section, what is the length? Length is square root 1 square plus 4x square root. If it is for ith section into delta xi. What about full? Then I have to add for all n. Summation sigma sign. Sigma summation I equal to 1 to n. Sigma I equal to 1 to n. Summation I equal to 1 to n. Ith section length. That is dp by dx magnitude. dp by dx magnitude into delta xi, or fx, function over x. Function over x for the ith section into delta xi, where n, summation I equal to 1 to n, where n tends to infinity, means each section is very small. This is a perfect case to bring it into integral calculus, because n tends to infinity and we cannot calculate it. If I want to convert a summation into integral calculus, then we already, integral calculus means if I take integral calculus need to have two things. One thing is function, any function, and another thing is the x-axis and function. If I say this function is gx dx, means this is gx and this is x. dx will give the area underneath it, from x equal to x1 to x equal to x2, from x equal to x1 to x equal to x2. From this section, gx dx will give area underneath it. This area I can divide into n different parts. If one part area, all part area, if I add, consider I have one. Now in this case, I have now 0 to 10. I am trying to find out this length. Okay, for ith section, if I divide 0 to 10 into n different chops, where n tends to infinity, first section, second section, third section, nth section. In the ith section, what is the length? Okay, in ith section, length is square root of 1 square plus 4x square. D, I'm sorry, it is, yeah, I believe it is all right. Square root of dp by dx magnitude came as a square root of 1 plus 4x square into delta xi. I can consider this expression. This expression has nothing to do with calculus actually. Integ Sigma sign, summation I equal to 1 to n tends to infinity. And then we have dp by dx magnitude delta xi. This part is the length of this curve for the ith section. If that is the case, then it is coming as a square root of 1 plus 4x square delta xi. What is the delta xi? Delta xi is 10 by n. Delta xi is 10 by n, where n tends to infinity. If I want to convert it to integral calculus has a form of integration. Gx dx. Dx is a continuous function and dx means x-axis. It will give area underneath it. Now let's rephrase this. Whatever we have done with the repeated summation, rephrase this. Summation I equal to 1 to n fx. 1 plus 4x square root can be considered as function over x. Fx into delta xi means if I take x-axis any delta ith section, then fx is the height into delta xi. This talks about this area. Height into width is the area of this subsection. If I add all the area of all the subsection, it is giving the full area. Full area is nothing but fx dx only. If there is a curve like this, that is called fx into delta x, that gives this area subsection. If I add all the area subsection, it is as good as fx dx. This is a fit case to transform into integral calculus. Now it will be transformed into integral calculus in a summation x equal to begin to n. I is gone now. X is 0 to 10. X 0 to 10. Fx dx or gx dx. Earlier it was fx delta xi. That is a subsection area of a full area. So nicely, straightforward, it can be converted to integral calculus. It will become a square root of 1 square plus 4x square dx. Someone can calculate, I don't know. Means it is very difficult, I believe. The square root of 1 square plus 4x square dx. X is from 0 to 10. If someone calculate, he will get the area of this line between 0 and 10. Integration 0 to 10. This is the usage of vector. Vector comes into the picture when we want the correlated x and y representation. If I say dy by dx, we have only two directions in which we are seeing the thing. One is x-axis, one is y-axis. If I want hybrid direction where x and y both are there, then I have to use another terminology where x and y is represented with it. That is vector. Vector had x and y both. That is xi plus yj. It has x and y both. Which has, if I say I have a vector xi plus yj, vector comes as energy, which has a direction, which has a magnitude. What is direction of xi plus yj? Depends upon what is x and what is y. What is its magnitude? X square plus y square root. Depends upon what is x and what is y. Okay, can I write vector as a magnitude and direction certain? Unit vector is called direction and its magnitude. I can rewrite it as square root of x square plus y square. That is the magnitude of the vector. And then what is the direction of the vector? xi plus yj divided by its magnitude, the square root of x square plus y square. This is a vector. If someone really understands the usage of vector, which talks about the correlation of all the independent variables, it can be. I have seen more or less nothing in term of artificial intelligence or machine learning, where we talk about feature. We have so many samples. Against each sample, we have set of feature. That is nothing but axis, x-axis, y-axis, z-axis. Okay, then we talk about which class it belongs to. But all are in terms of x, y, z only. Okay, people try to represent it as a vector, that is x1 I plus y whatsoever, but it is limited only. I have seen that much, but very limited. Okay, so this is the arena we will proceed little what, calculating more things, and then someone can apply this concept in real science of the machine learning. That we will see. These explanations are not there in any of them. Please try. You can try. Please support us. Don't mind supporting us. Mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.